This is the prerequisite worksheet for section 3.3, division of polynomials and the remainder and factor theorems. We will begin with objective 1. We have 3 on this worksheet, and that will be multiplying complex numbers together. So let's begin with 8i multiplied by 3i. So we multiply the numbers together first, and then I times I is I squared. And keep in mind, I is the square root of -1, so I squared is -1. So now we have 24 times -1, which will be equal to 24, but we want to go ahead and write that as 24 plus 0i, since they've asked us for this form, a plus bi form, and that's our standard form. Looking at number 2, we're going to distribute the 6i, so it's 6i times 1 minus 6i times 3i. So we end up with 6i minus, and 6 times 3 is 18, I squared. So that's 6i minus 18 times a -1, and we end up with 6i plus 18, and then let's go ahead and write it in a plus bi form. So in our standard form, a is the real part and b is the imaginary part. Okay, in number 3, we will have -i times 3 plus -i times 4i, just taking our time. We have a -3i, and then we have a -4i squared. So we have -3i minus 4 times a -1. That's a -3i plus 4, and we have 4 minus 3i. Looking at number 4, we are going to FOIL. So we have first, outer, inner, last. So as you can see, we are able to combine, the inner terms, and we will have 8 plus 2i minus 21 times a -1. So we have 8 plus 2i plus 21. So we end up with 29 plus 2i. Okay, looking at number 5, we now have 4 plus 5i all squared. So let's go ahead and write 4 plus 5i multiplied by 4 plus 5i. And let's go ahead and FOIL. First, outer, inner, and last. Again, we can combine our outer and inner terms. And then we have 25 multiplied by a -1. So that's a -25. And we end up with -9 plus 40i. Next, we have 3 minus 2i all squared, and that's 3 minus 2i multiplied by itself, 3 minus 2i. Let's go ahead and FOIL. First, outer, inner, and last. Here, you see outer and inner are the same, so we have a -12i plus 4 times a -1, and we end up with 5 minus 12i. Okay, taking a look at objective 2, here we are going to verify. So if someone says to verify, we already know that it's going to work. It's already going to be able to be, it's already true. So let's go ahead and see. We are going to substitute the given values of x, and we are going to show that they are solutions. We are going to show that they satisfy the equations. So here we are going to have x equals 3 plus I. Let's verify that this is a solution. So we have 3 plus I all squared minus 6 times 3 plus I plus 10. We're going to see if that's equal to 0. So this is 3 plus I multiplied by 3 plus I minus, I'll go ahead and do all of this at once. I won't distribute that negative 6 yet. Okay, let's go ahead and multiply 3 plus I times 3 plus I. First, outer, inner, last. Then we have negative 18 minus 6i plus 10. Now, here you can see that our 6i's cancel. I really wanted to do that in blue, but let me go ahead and simplify this. So we have 9 plus 6i minus 1 minus 18 minus 6i plus 10. So now we have our 6i minus 6i. So here, as you can see, we have 9 minus 1 minus 18. So that's 8 minus 18 plus 10. And as you can see, that's equal to 0. So we have just verified, therefore, and you know what? Let's make this just a tad bit smaller. And then I can write this. Therefore, x equals 3 plus I is a solution. Okay, let's take a look at 3 minus I. We'll do the same thing. We will have 3 minus I all squared minus 6 times 3 minus I plus 10 is equal to 0. And then that's 3 minus I multiplied by 3 minus I. And we'll wait to distribute this negative 6. And here we have outer, first, outer, inner, last. We'll go ahead and distribute that negative 6. And as you can see, we have 9 minus 6i minus 1 minus 18 plus 6i plus 10 equals 0. So our 6i's cancel. And we have 9 minus 1 minus 18 plus 10. And again, we have 0 equals 0. Therefore, x equals 3 minus I is a solution. So here we are just substituting these given values, and we're showing that they are solutions. Okay, let's go ahead and look at number 8. Here we will substitute negative 2 plus I root 2 in for y. So if we go ahead and give that a try, we're going to have negative 2 plus I root 2 squared plus 4 times negative 2 plus I root 2 plus 6. That's negative 2 plus I root 2 multiplied by itself. And I'll wait to distribute. Probably am getting a little big with my writing. Okay, so now we're going to multiply first, outer, inner, last. So last is plus 2i squared minus 8 plus 4i root 2 plus 6. So as you can see, we'll go ahead and just try to simplify a little bit more. We have 4 minus 4i root 2. And then this I squared here is a negative 1. So we have a minus 2 minus 8 plus 4i root 2 plus 6 equals 0. And you can see that our 4i root 2's cancel. So here we have 4 minus 2 minus 8 plus 6 equals 0. And we have 2 minus 8 plus 6, negative 6 plus 6, and 0 equals 0. Therefore, y equals negative 2 plus I root 2 is a solution of that given equation. Okay, let's go ahead and take a look at B. Again, we have y squared plus 4y and then we have plus 6 equals 0. And this is negative 2 minus I root 2 multiplied by itself. And we'll go ahead and multiply those two binomials, 4. So outer is a positive 2i root 2. Inner is a positive 2i root 2. And last is a positive 2i squared. So here we have a positive. We have our I squared, and we have root 2 times root 2. Okay, let's distribute that 4. And as you can see, we have 4 plus 4i root 2 minus 2 minus 8 minus 4i root 2 plus 6 equals 0. And we have our 4i root 2's cancel. And we end up with 4 minus 2 minus 8 plus 6. And 0 equals 0. Therefore, y equals negative 2 minus I root 2 is a solution. Okay, let's take a look at objective number 3. And here we are going to be using the quadratic formula. And the quadratic formula will solve any quadratic equation. So the quadratic formula, you can solve any quadratic equation with it. Okay, so we're going to write it each time we solve right at the top, right before we solve it. So for this given quadratic equation, we have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So for our equation, maybe I should have written that first. For our equation, we will always write down A, B, and C. And that is going to help us very much. And then we will use that. And I will go ahead and write that like that. So let's go ahead. X is equal to the opposite of B. So the opposite of -4 is a +4. Plus or minus the square root. B squared is 16, right? B squared is 16. Minus 4 times 1 times 5. All divided by 2 times A. And 2 times 1 is 2. So we have 4 plus or minus the square root of 16 minus 20 all over 2. Okay, let's keep going. So X is equal to 4 plus or minus the square root of -4 all over 2. And X is equal to 4 plus or minus 2i over 2. So if we go ahead and split this up and divide each part by 2, you can see that we have 2 plus or minus, I did not want to be in that blue, we have 2 plus or minus I. Okay, let's go ahead and do the same thing for number 10. We do have to be in A squared or X squared plus BX plus C form before we begin. So here I'm going to add 2A to both sides, and we will have A squared plus 2A plus 10 is equal to 0. We have A is 1, B is 2, and C is 10. So here, our quadratic formula is A is equal to the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So A is the opposite of 2 plus or minus the square root of 4 minus 4 times 1 times 10 all over 2 times 1. So we have -2 plus or minus the square root of -36. Write that a little bit better. So 4 minus 40 is -36 all over 2. So we have A equals -2 plus or minus 6i over 2. Let's go ahead and divide each term by 2. And as you can see, let's see if I can compress some of this. There we go. And so we end up with -1 plus or minus 3i. And that concludes this worksheet.